Hello, this is Rick Powers making a video recording for Basic Statistics, lesson number 14. Hello, this is Rick Powers from Western Technical College for Basic Statistics. Lesson number 14, probability counting rules. One aspect of working with probability is the process of counting. Generally, we think this is an easy process, but there are situations where figuring out the number of items in a set can be pretty complicated. In this lesson, we will work through some of those situations. Please note, I do not consider this topic to be of central importance to making progress in an introductory course. However, it can be a way to figure out some of the foundations of how probability works, and it does play a role in applied problems that come up on occasion. The first situation has already been considered. When we make another choice, we multiply by the number of options. For example, roll a standard die and then flip a coin. We get 12 options, since 6 times 2 is 12. Consider a situation where we are working with making multiple choices out of a single set. For example, choosing president, vice president, and secretary out of a group of club members. The same multiplication holds, but it holds the key to later understanding. Specific example. How many options do we have if we pick president, vice president, secretary out of 10 math club members? For the first choice, all 10 are available. For the second choice, only 9, since one has been chosen. For the third, only 8. So the answer is 10 times 9 times 8, which is 720. I hope it's clear that this process works when we are choosing without replacement. That is, once a person is chosen, they're not considered for later choices. Another way to say this idea, repetition is not allowed. It's also true that the order of the choice is important. The 3 roles are not the same, president, vice president, secretary. So whoever is picked first will stay as the president, as a distinct choice. The results that we get are called permutations. So choosing 3 out of 10 will create 720 permutations. This pattern of multiplication by decreasing numbers has a special mathematical symbol, which we can use to write a formula for this process. It's called the factorial symbol, and it is the exclamation point. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. 10 factorial is 10 times 9 times 8, times 3 times 2 times 1. In order to get 10 times 9 times 8 in our example, we use 10 factorial divided by 7 factorial, since dividing will cancel out every number from 7 on down. So here's the formula using n for the large set and r for the number of choices. NPR is equal to n factorial divided by n minus r factorial. However, it's not necessary to use this formula when finding permutations, since graphing calculators, spreadsheets, and websites can determine permutations with just the input of n and r. Your textbook has instructions for using technology. There is another situation that often comes up regarding choices in which the order of the results is not important. In our example, this would happen if we wanted to just choose 3 people for the social committee out of the 10 members. To make this list of outcomes, we want to combine all the permutations that have the same items. So these are called combinations. Consider the example again. If there are 720 permutations, then we can combine the ones where the same 3 people were chosen. So now we have 2 requirements. No repetition chosen without replacement. And the second requirement, order is not important now. Now, if you want to know how we make the formula for this, side note, think about how many permutations will have the same elements. Example, how many ways can I pick 3 people in a specific order if I use the same 3 people? And the answer is R factorial. Here then is the formula for combinations, where I choose R items from a group of n. NCR is equal to n factorial divided by, in the denominator, R factorial times n minus R factorial. These numbers have many interesting properties which will be useful later on. One application is the binomial coefficients, which are used in algebra. Another application is Pascal's triangle, which is a special geometric arrangement of the numbers. 1 in the first row, 1 and 1 in the second row, 1, 2, 1 in the third row, 1, 3, 3, 1 in the fourth row, and so on. Later, we will see these numbers in relation to coin flips, the game of Plinko, political polling, and the bell-shaped curve. Note, once again, it is not necessary to use the formula to get these numbers since we have technology to do so. End of lesson 14.